This is one fat analysis tool which we designed, and these are the 4 options available. The first option is binary threshold. So what it does is normal threshold, but threshold the image in 2 different colors. So first I will select the option raw image and select this image. This is a raw one, and this is one manually tagged image, or the other name for this is ground truth image. So as of now I will be selecting raw image, and here I will place the threshold value where the color range is between 0 to 255. I can select anything between 0 to 255, but for this image I'll be selecting 228, and mostly using our tool. And for HNE images, fats mostly range from the color 221 to 255. Yes, somewhere between that. This is what I have observed. I did not get to know this value from any official data, just my observation. So since I have selected 228, now I will click on the submit button. So it has been thresholded. Now the next option is segment white pixels. So as you can see, the image has been divided in 2 colors. I'll show you in the large format. So this is the thresholded image. So what the segmentation option will do is it will segment this as one, this as one, and say this, since it is continuous, these as one, and this as a separate one. So I'll go to this segment white pixel option, and then open this thresholded image. Then I'll click the submit button. So the segmented data has been stored in these 2 files. I mean, the image what you see is not saved in display. This is only for display, but the segmentations are saved in 2 files, combined and segmented. You don't have to know exactly what is combined and what is segmented, but these are 2 files in which the data is stored. And then I'll go for the third option, which is quantify fats, and I will open raw image, then thresholded image, and I will select the option default. Why default? Because in these 2 files, as of now, I have not manually changed any of the default generated names. If in case I do, if in case I add say 1 after this combined, or say new after this combined, then I need to manually give the location of that file, or even open from here. But since I have not changed, I will select the checkbox like use default. Now I'll have to select the color by which my fats will be tagged. For this I'll be selecting cyan blue, and now the next option is to give a range of fat size, say minimum and maximum. For this image I'll be selecting 22. I'll be assigning 22 and 190. So fats will range between 22 and 190. Like in our image, this is not a fat. What I was told, that this is not a fat and these are fats. So if I go beyond 190, say 250 or 300, in that case maybe this may get identified, but we don't need this. We need only these ones, say these ones. So since I've entered all the filled up all the parameters, now I'll select the option submit. Yeah, done. So this is the area covered by fat, and sometimes like if users need the percentage of fat covered area, then what they need to do is, since they have obtained this area, they need to divide this area with the area of the image, which can be identified by the dimension of the image. So yeah, like that they can find how much area fat is covering. But till here the normal fat identification process is over. But if in case someone wants to validate, like what is the accuracy of identified fat, then they need to go for the option validate identified fat. And we can see that in this option it requires manual tag data. Initially I have shown you one manual tag data, what we need to use it now. For that we need to do thresholding and segmentation of that data. So I'll click on this manual tagged image, open this one as I showed you previously. This one I'll open, and for that we also need to mention in which color the fats are tagged. So here it is yellow. This is the color value what was used to tag this. So I have selected directly this yellow, but if in case you tag it with some other color, say red is say 260 instead of 255, so you need to like manually set the color value here. So I've set it, and I'll click the option submit. The thresholding is done, and just like before, again I'll select for segment, and I will see now we have two thresholded image, one for the raw and one for the tagged or the ground truth image. So I'll select the thresholded image of which was generated as per the ground truth image. So I'll select this one. So it has been opened, and now we will be selecting this checkbox. Previously for raw image we did not select this checkbox because it was not necessary, or it was not meant for raw image. So here I'll select this checkbox and click on submit. So it has been segmented, and for ground truth image or tagged image we don't need to do anything in the option quantify, but we will then come to the last option, validate identified fats. Open machine tag. We will see that machine tagged image is the blue colored image of fats, where those are marked with the color blue or cyan. And then open manual tag. This is the unthresholded image, yellow, and use and set all these values to default. So these files are basically this one and these four. This use default file name for empty spaces touching boundary. This is basically this file. And manual tagged image, the first checkbox. If in case like you have changed, then these are these two files, combined manual, segmented manual. And this one I already discussed previously, machine tagged fat area. This is like till combined and till segmented, not manual included. So since I have not changed the names of these files, so I have checked all the checkboxes that use default. Now I will select the color for machine tagged, which is cyan blue. Manual, we know it's yellow, and intersection color value is basically what is common between both. So here I'll be selecting this something mixed between yellow and blue, kind of like green. I'll be setting the intersection value with this color, and now I'll click on the submit button. So this is the output what I received, and this file will be saved here with the name comp. This is the output. Here you can see that what was common between the machine tagged and manual tagged has been marked with this color, like somewhat like green, and here the green part is the true positive part. False positive is basically yellow part. Sorry, false positive is basically the blue part. My bad. False negative is basically yellow part which was not covered by the green part. And then intersection over union, this value ranges from 0 to 1, which in terms of percentage for our analysis it's 95.3. For some other image it may vary, like it can go down to 80 and can even range up to say 99, but it depends what image you are using and how the ground truth image was tagged. Like if the ground truth image is more accurate and it's sometimes it's different, then this intersection over union value can also change. So, and these are the files generated. I will show you. This is the comparison file, and this is the normal machine tagged file. These are the two files. These are the two output images which has been generated. So that's all about our tool. If you like our tool, then you can use it by going to the link mentioned in the description. Thank you.